Thank you. Thank you very much. It's a real pleasure and honor to be here. I'm going to tell you a little bit about artificial environmental intelligence with high-flying, far-walking, and deep learning. This is a list of applications of machine learning taken directly copy-paste from Wikipedia. And if you take a quick look at this list of applications, obviously it's not exhaustive by any measure, but this is most of these applications are kind of very urban and kind of geeky, if I may say so. There are a few that are very generic, so they are about analysis of time series in general, so they can be applied for environmental applications as well, but there is not a single application here that is explicit, talks about the environment. So this is an obvious bias of the community towards this kind of applications. And I want to raise your attention towards, draw your attention towards this big and beautiful world of environmental applications that is out there and is really waiting for your attention and talent to address all of these numerous, very significant and interesting problems. So one problem with natural environment, environmental sciences, and one reason that the machine learning has not been as widespread there is that the data is very complex. The problem are very multidimensional, multi-scale, multimodal. Model data is fragmented and noisy, and the collection of data is actually hard. You actually need to leave the comfort in your office and basically go out there and collect the data. And this doesn't scale well, and it's hard to do. And I spent most of my career, I was lucky enough to basically chase environmental data. I did it with submarines and drone submarines and planes and boats and zeppelins and all kind of aircraft, pretty much all around the world. And in 2012, I kind of got my hands on what I thought was the ultimate source of environmental data, and it's called Hyperspectral Imaging. Basically, what it allows you to do is to analyze molecular structure in every pixel of your image, and you can do it on a very large scale. It can produce just gigantic amounts of data, and more importantly, information. It's a very information-rich data source. And we built this instrument, and we took it for a ride from Lake Geneva all the way to Lake Baikal in southern Siberia with this little funny aircraft, 5 of them, in fact. And we collected some dozens of terabytes of environmental data. And one of the things that we really learned is that hyperspectral imaging is extremely effective for analysis of vegetation. You can basically tell everything about every single plant. You can say which species it is, what's its metabolic state, what its physiology, which nutrients it lacks, if it's affected of disease by disease or particular pest, etc. At least in principle, if you know exactly what you're looking for. And so we thought this can be really useful for, let's say, agriculture. So we decided to create a company, and we decided to bring this technology, hyperspectral imaging, to this $5 trillion global industry, which sounds like a really good idea. Except that it's very, very hard. And in fact, I would say that if there wasn't for this wave of machine learning tools that came out in the last few years, we wouldn't be able to get far. But we were very lucky, and now we have these few applications that we really know a lot about it. And I want to give you an example of one of the domains where we work, which is the sugarcane industry. And the sugarcane industry, this is what you use to produce sugar. This is what you put in your Swiss chocolate. And the total area covered by sugarcane today for commercial production of sugar is 26 million hectares. So just to be clear, this is not the area of the region. This is the actual netto area covered by sugarcane plants. And this is more than 6 times the area of Switzerland. Just continuous sugarcane horizon to horizon. There's also the greenhouse gas emissions of 80 million tons, which is twice the total footprint of Switzerland, including all of its industries, etc. And also the turnover of this industry is 50 billion. So what they do is they have this very large farms of, let's say, hundreds of thousands of hectares, and they have thousands of fields. And each field, you have a few dozens of important agronomic parameters that they need to tune to reach the optimum result. And they do it more or less with a lot of driving their trucks through these fields with a very large team of rangers. And then they do all their calculations in Excel at best, in spreadsheets. And some of them just print it and look at printed PDFs. So there's obviously there's a good chance that there's a better way to do that. And the impact of this relatively simple optimization can be just tremendous if you compare to some other applications. It can affect millions of people, and it can have a dramatic effect on, let's say, carbon emission, if you are interested in this kind of thing. So this is a few examples of very simple things that we do right now, such as, for instance, optimization of planting efficiency, so analysis of planting failures that allows these farmers to actually replant sugarcane when it's needed, or detection of soil erosion that avoids them to get their machinery stuck in erosion channels, or detection of weeds that can reduce the amount of herbicide that they use, or prediction of yield for the optimization of harvesting. And here are a few other examples from our work on tobacco, where we detect tobacco virus and we detect weeds, and we estimate plant maturity, and we do soil compaction and several. There's a whole bunch of different things. And we got lots of prizes for our work, including NVIDIA Inception Prize for AI. But there's something more interesting, I would say, and profound that came out of all of this work, is that we kind of slowly start to be able to combine different scales together. And we kind of starting to develop a system that would have awareness not just of specific plants, but also fields and farms and regions and soil types and the whole continents. It's a kind of very interesting emerging complexity that we call environmental intelligence. And it's just very small baby steps towards that, but I think we are moving in the right direction. And so we are building this, or at least trying to, and I think we have some good ideas, building this environmental intelligence platform where we collect data from satellites and drones and weather data and ground samples, ground sensors, and we pass them through this AI, artificial environmental intelligence engine, and then we feed these results as recommendations, as decision support to the farm machinery and farmers for inspection and monitoring and heuristics. And then we feed back the results into the AI engine to learn from it continuously. It's not quite the case today. It's not exactly how it works today, but this is what we are working towards. And so what I want to show you here is a little video. These are all of the satellite data from multiple satellites that is available for a particular place in Brazil with sugarcane fields. And if you noticed here, there are data from different satellites. So it has different resolution, different spectral bands, different temporal resolution, etc. It's very quite different sources of data. And they are not, if I maybe very quickly run it again, you would see it's kind of all disconnected. You don't really see what is happening here. But then, if we feed all of this data into our engine and we combine all of this different data across different scales, you start to see something very interesting. So this is all the data from all these different satellites, different scales put together. So you start kind of see these processes happening and kind of the system anticipating what is going to happen. And there's this very clever interpolation and extrapolation that is happening here. You actually see fields growing and then being harvested and then replanted with different crop, and then the cycle repeating itself. So there was a pause, winter pause, and then you see this process again repeats itself, and you have these stages of rapid harvesting where the field is emptied and then it grows again. So this to me is quite fascinating, and what it shows is that the system actually develops this intuition about the environment, which is, to me, is really quite remarkable. And so to just summarize this very short talk, is that I think environmental intelligence presents some of the most compelling, challenging, and profound applications for machine learning and AI in general. And if you agree with me in any way, if you are a student or you are working for trying to solve some optimization problem for large corporation, you should really reach out and perhaps consider joining us. So thank you very much.